I'm happy to announce Renaud Lifchitz and his talk, Android Geolocation Using the GSM Network. And the subtitle is, Where was Waldroid? I hope we're going to learn what this is, what this is going to be. So I think we're good to start. Renaud.
Thanks. Hi, everybody. Welcome to my talk. First of all, let me introduce myself. I'm Renaud Lifchitz, coming from Paris, France. I'm a computer security engineer. I do mainly penetration testing, security trainings, and security research in my company. And my main interests are security of protocols. That means authentication, cryptography, information leakage, zero-knowledge protocols, and so on. And another interest is number theory, probability testing, factorization, and so on. So don't worry, there won't be any math theorem or complex proofs in my talk. Don't bother with that. So first of all, why Android and not iPhone or BlackBerry, for instance? Why not? In just 2 years, in fact, Android has made an impressive market share. Okay, so for now, nearly 300,000 phones are activated each day, according to Google, Andy Rubin, who is the director for the Android part of Google activity. And now Android sales overtake iPhone since summer. So Android is now a big part of the phone nowadays. And the last point is because hacking with Android is very cool. You have a true, real Linux kernel, so you can hack many, many things. So these are the market shares for Android phones, iPhones, BlackBerries. So you see now Android is becoming the second largest market share in the US. Well, no, let's talk about the geolocation, because this is far more interesting than the little introduction. So to geolocate a phone, you have different ways to do that. Okay, you can use the integrated GPS you have on most phones. Okay, the GPS is very accurate. You can have a 3 or 4 meter precision with the GPS. But the problem is that you need a GPS in your phone. This is not the case for all phones nowadays. Okay, and the user must switch it on. Okay, it's not enabled by default because of the battery consumption, right? Another problem with the GPS is if that doesn't work inside the buildings because you don't have the satellite view, nor underground, for example, in the subways. Okay, so you can't locate yourself in the subways or in the buildings. So that's a problem. Another way to geolocate yourself is to use Wi-Fi. Okay, Wi-Fi, on the contrary, works inside buildings. So you can locate yourself at work or at home. No problem with that. But you need Wi-Fi on your phone. You need to switch it on. And it's far less accurate than GPS because the coverage for a Wi-Fi access point is about 300 meters. Okay, so it's not very accurate. Okay, and you need, of course, access points in order to triangulate your position. Okay, if you don't have any access point near your building, you won't be able to locate yourself, right? So these are the two classical ways to locate yourself. The last way, and the most interesting way, is the GSM location, right? So here you don't need a Wi-Fi or GPS. So it will work with all GSM phones, okay? And it can be done from the network side. You don't have necessarily to install an application on your phone to have a smartphone, okay? With a very old phone, you are able to geolocate yourself because this is made from the network side, okay, and not from the user side. The disadvantages are you have a very low accuracy, okay. GSM cells can extend to nearly, I think, 30 kilometers. So in cities, in big cities, there is no problem because there are lots of BTS, that is to say GSM access points. So in the cities, you have a quite good accuracy, which can be a 100 meter. But when you are far from the city, for example, in the seaside, you won't be able to geolocate precisely, okay? And of course, you need GSM coverage, but it's easier to have GSM coverage than to have Wi-Fi coverage. So how does it work? How can you locate yourself using GSM? You have to know that every GSM cell, every BTS, which means base transceiver station, is identified by actually 4 numbers, okay? First number is MCC. MCC stands for Mobile Country Code. This is the country code you are in, okay? So these are normalized codes, which are not the prefix you dial on your phone. These are other codes, okay? For instance, in Germany, it's 262, right? Second number is MNC. MNC stands for Mobile Network Code, and this is a code for the operator, for the network operator, right? For T-Mobile Deutschland, for instance, the code is 1, okay? Because this is the first network operator in Germany. Third number is a code about the area you are in, okay? So cells are grouped into areas, and usually big cities are divided in 5, 6, 7 large areas, which can be more for some cities. And in an area, you have different cells. So the last number is the cell ID, which is the code for the ID in the area, right? So with these 4 numbers, you are able to know in which cell precisely you are. Right. So this is not new. So there have been several attempts to build databases of GSM cells, because it's not easy to have a clear mapping between those 4 codes and, for example, GPS position. Okay, the cells are attributed by network operators, but they keep the database for themselves. So the cell positions are not public, right? So there have been attempts to build database of all cells in many countries, in many operator networks, right? So you have, for example, location.api.com, which have nearly 11 million cells in the database in more than 200 countries, right? So you can find all those databases in Wikipedia, right? So this is a first try to geolocate yourself using only cell IDs. But why not use something more efficient, like Google indexing power? Okay, instead of indexing yourself cells, okay, which means a lot of effort, okay, a lot of human task, human power. Why not use something completely automatic, which is regularly updated, like the Google indexing power, right? So how does it work? It works using Google cars. I'm pretty sure you have already heard about Google cars. These are the cars that build the Google Street View, okay? That takes pictures of all streets, okay? The Google cars not only take pictures of streets, house, and all the surroundings, but also index all Wi-Fi access points and all GSM BTS, okay? So they have a pretty complete database of GSM cells, okay? They keep it secret, but they have it, right? And they have not only the Google cars, they have all Android users also. Because your Android phone is constantly updating this database when you use, for example, Google Maps, okay? So all Android users are updating this very large Google database. So this is continuously updated and quite good quality. But is there a Google API somewhere? Okay. Yes, but it's quite confidential. Quite confidential. There is a Google API. In order to be sure there is a Google API, try to run a Google Map with the GPS and the Wi-Fi disabled. Okay? So your phone will only be able to geolocate using GSM, right? So I have tried this, and I have seen there is some kind of API the phone uses to be able to geolocate, right? Another entry point to the API is when you install a Google GIS plugin. It's not so much known, but it's a plugin for Firefox and Chrome, which allows, for example, cache browsing or local search. I mean, when you type restaurant in Google, it finds the pizzeria just in front of your building. So Google is able to know where you are, okay? Just by sniffing the query from the Google GIS, you are able to figure that there is an API, right? But this API, of course, when you are running a local search, doesn't use GSM because you don't have a GSM receiver in your desktop computer. So it's only using Wi-Fi access point, right? So first of all, let's talk about Android Google Maps internals, right? So I have compiled a TCP dump for my Android phone, which is a Nexus one. So you need to cross-compile TCP dump for ARM architecture, because of course the phone doesn't run an Intel processor, right? And I noticed there were some exchanges in binary. So this is a proprietary binary protocol, right? But it uses HTTP, and